Right, this is day 4. We're going to be covering taxonomy of organisms today. I'm doing a virtual version or a video version just because I'm assuming that we're either in learning in place because of testing, or maybe you are testing. That doesn't excuse you from doing this review though, because English and biology are considered STAAR tests. So you still need to do this one. Make sure that you do open up the cheat sheet / the note sheet underneath the Pear Deck post for today to work and use it along with today's Pear Deck and the exit ticket. So to kind of introduce again what taxonomy is, it is a classification system that we use for categorizing and identifying all living things that we know exist. It kind of creates a hierarchy based on characteristics that are physical or genetic to put organisms that are similar together and then organisms that are not as similar into different groups. It's kind of like a family tree of all life, and the levels go from kingdom as the most broad, phylum, class, order, family, genus, species as the most specific at the very end. And as you can see from this kind of weird diagram, the kingdom is broken down into multiple phyla. And when you take one phylum and you open it up, there are multiple classes inside of it. When you take one class and you break it up, there's a lot of orders inside of it. One order, break it up, there's a lot of families. One family, break it up, there's a lot of genuses. And then inside of a genus, there's different species. But the species, there's only one thing, and it doesn't break down into anything smaller or more specific. So the man who created taxonomy, or the father of taxonomy, is Carolus Linnaeus. And he created another system called binomial nomenclature, which is what gives us the scientific names of organisms. And scientific names come in a 2-part Latin name. And that makes it really easy for scientists to communicate about new organisms that they discover, or organisms that maybe have already been discovered that they're now first experiencing or encountering. The names also help us identify how closely related two organisms are just off the bat, because then when you know if they have the same genus or the same species, then you can tell how closely related they are. If their scientific names are completely different from each other, then you would go back and look at kingdom, phylum, class, order, family before you look at the genus and species, because those two are different. As a summary of the past few slides that we just went over, I do want you to pause and then go ahead on this slide, write, why do we use the taxonomy classification system? What is it used for, and why is it useful? There were multiple reasons that I went over, but I want you to pause and type out an answer for me. Now, taxonomy keeps relationships between species and their ancestors organized for us to reference and look back. It also allows scientific communities to talk about organisms even in different languages, because the Latin scientific names are uniform across all countries. This makes it easy to communicate about extinctions when species end or disappear, and also discoveries of new ones to make sure that we're not double dipping and counting new ones more than once. Taxonomy works based on 3 major things that we analyze. And the first one is DNA, the next one is structure, and the third one is behavior. I do want to be clear that the taxonomic system is still growing to this day. There's no real end point, because there's always new species that are popping up. And then also we're getting better and better at analyzing DNA structure and behavior through new technology. Now, taxonomy, like I said before, isn't a system where we go kingdom, phylum, class, order, family, genus, species. And unlike the energy pyramid, it's actually reversed, where the kingdom is the largest group. It's the most broad group, and it contains very many organisms. For example, the entire kingdom of animals, or Animalia. Right? Within a kingdom, you'll have multiple phylums. Within a phylum, you'll have multiple classes. Within a class, you'll have multiple orders. Within an order, you'll have multiple families. Within a family, you'll have multiple genuses. And then within the genus, you'll have multiple species. At the point when you get to species, though, it's really specific, and there's not that many differences in the organisms. Whereas in the kingdom of Animalia at the very top, you can have things that are like beetles versus giraffes. Now, at a cellular level, they're really similar, but on the broad scale, when you just look at them, you can already tell they're really different. So the way that we use these kind of levels or tiers in our taxonomic systems is that we can get more and more specific as we go down based on characteristics of organisms. And so here's an image of a jaguar, and the scientific name is Panthera pardus. And I want you to notice that, again, the scientific name is 2 Latin words, and they're always italicized, or that like slanty kind of thing that you do on Word documents, right? The genus is always first and it's capitalized, and then the species is second, but it's never capitalized. Now we know that the jaguar belongs to the kingdom Animalia just from common sense, right? It's an animal. We also know that more specifically within the kingdom of Animalia, it belongs to the phylum Chordata because it has a chordate, or it is a chordate because it has a spinal cord. Now within all of the chordates or the Chordata phylum, the class that it belongs to is Mammalia because, there are chordates that are not mammals, for example, like lizards. They have a spinal cord, but they're not warm-blooded. But we know the jaguar is a mammal because it's warm-blooded, it has fur, and it produces milk for its babies. Within that class, there's a specific order called carnivora because the jaguar belongs to it because it eats meat as a carnivore. Within carnivora, there is a family of Felidae, which is cats or felines. Now, within that family of Felidae, there is a genus called Panthera, which is a type of panther or big cat. And as we know, jaguars are not house cats, they're big cats. And then lastly, within the genus of Panthera, there is Pardus, which is only assigned ever to jaguars. It is specific to them and is special to them. So it is a species name. The more levels an organism shares with another organism, for example, kingdom, phylum, class versus kingdom, phylum, class, order, the organisms will be more closely related if they have more that are together and similar. For these two examples, I'm going to ask that you go ahead and place the green star on the genus of the names Equus, Cabias, and Canis lupus, and then the purple heart on the species part of the names of Equus, Cabias, and Canis lupus. I do want you to recognize that there's going to be 2 genuses and 2 species, so you need to mark all 4 individually for me. Another thing in taxonomy is just memorizing the levels of the hierarchy. And so we have kingdom, phylum, class, order, family, genus, species. Now, those are just kind of a mishmash of words. If you say them enough like I do, you're going to memorize them. But there are mnemonic devices that help you remember them because a sentence is going to be easier to remember than just a mishmash of random words. And so a really common one that we use to represent the letters of kingdom, phylum, class, order, family, genus, species, or KPCOFGS, is a sentence that starts with each of those letters. King Philip came over for great soup. Now, you might be thinking, I don't really care about King Philip, or I don't know King Philip. I don't care about soup. So I'm going to ask that you make up one on your own, just to see how creative you are. And also, if you make one up, you'll probably remember it better than one that I tell you or one that I give you. So take some time to make up a sentence. Each word of the sentence must begin with the letter K for the first word, P for the second word, C for the third word, O for the fourth word, F for the fifth word, G for the sixth word, and S for the seventh and last word of your sentence. Good luck on this one. It is kind of hard, so take your time. The next part of taxonomy that I do want to talk about is a cladogram. And a cladogram is a really nice visual representation of the evolutionary relationships between animals and species in general. So we can represent an entire species on a branch just by talking about a hagfish or a perch, or just all perches and all hagfishes in general. And cladograms are kind of nice because they're marked by the characteristics that differentiate each of these groups of organisms or each of these species. So if you are on the left side of one of these demarcations, that means you didn't develop this evolutionary trait. But if you're on the right side, then you have this evolutionary trait. For example, here we have fur and mammary gland. We know that mice and chimps have fur and mammary glands, so they're on the right side of this branching. And on the left side of the demarcation, we have pigeons, lizards, salamanders, perch, and hagfish, all of which do not have fur or mammary glands to produce milk. These evolutionary traits are like derived characteristics. They're kind of different. They separate out these groups, and they kind of show along the lines of when organisms were developing in the past, in the history, which characteristics popped up earlier and which characteristics popped up more recently. So again, this is just me explaining that when you read a cladogram, you see ages ago as the beginning or the earlier stages. And then as time goes on, it moves until the current time or now. And the reason why this makes sense is because all of the organisms that you talk about that are in a line at the top or on the side of a cladogram, they're all in a straight line together because they all currently exist. The branching events are signaling that because of evolution, these organisms either have this trait or don't have this trait. I want you to go ahead and drag and drop. I want you to tell me which organism is the least closely related to birds, crocodiles, rabbits, and primates. Now the emphasis is on least closely related. The next thing we're talking about is a dichotomous key. You guys are pretty good at using these ones because it's like that yes, no, go to step 2, yes, no, go to step 4 key that you identify organisms' names or organisms' general characteristics by. It's not usually really a diagram form that we use. We usually use more of like a table or a key, but it can be represented as a diagram, and it identifies organisms based on their observable characteristics. So you're not going to be asked on a dichotomous key to talk about genetics or behavior. It's usually going to be physical traits of the organism. And it's nice to use because it's a yes or a no. It's black or white, left or right, right? You either have the trait or you don't have the trait, and then you move on to the next step of identification based on whether or not an organism has a characteristic. So here is a dichotomous key, and you always start at step 1, just like a recipe. Okay? You're going to read the instructions under step 1 and follow the next step based on whether or not the specimen that you're referring to has or does not have that characteristic. And you'll repeat that until you go all the way down to the name of the specimen. So here we're going to start at step 1. And it says, A, if the fish shape is long and skinny, go to step 2. B, if the fish shape is not long and skinny, go to step 3. I'm going to ask that you go ahead and look at this specimen down here next to the yellow box, and then figure out what it's called, starting with step 1. Now the answer is that it's a spotted eagle ray, because if you follow step 1, it says the fish shape is not long and skinny, so we'll jump to step 3. In step 3, we're going to read A and B. Now we skip step 2, so you do not have to read it all. It's not important to you anymore because it doesn't apply to the specimen. In step 3, it says if the fish has both eyes on top of the head, go to step 4. If the fish has one eye on each side of the head, go to step 5. And so we know that the fish has both eyes on top of its head. They're kind of hard to see here, but they're just kind of pointed right here at these two little nubbins. We're going to go to step 4, and it says if the fish has a long whip-like tail, it is a spotted eagle ray. But if the fish has a short blunt tail, it is a peacock flounder. Oh, looking at that tail, it's definitely a long whip-like tail, so it is a spotted eagle ray, and therefore we have our answer. Let's do some guided practice just to kind of walk you again through the RAKE method. We're going to read and highlight, ask the question in our own words, share the knowledge that we have on this background, or if you don't, you may use the notes cheat sheet to help you out and supplement your knowledge, and then eliminate and choose the best answer choice. The example we'll do is here. It says the relationships among different orders of millipedes are shown in the cladogram. So we have a visual cladogram here with different millipedes. Hopefully y'all know what millipedes are. Based on this cladogram, which statement best describes relationships among millipede orders? F says Stemulida is more closely related to Mariquita than Penicilliata is to Mariquita. G said Spirostreptida is more closely related to Glomerita than Spherotherida is to Glomerita. Now these names might be really hard, but they're all on the table, so you can always point them out or circle them or star them as you're going through. H says Polyzonida is more closely related to Glomerodesmida than Spherotherida is to Glomerodesmida. Lastly, J says Mariquita is more closely related to Glomerodesmida than Glomerita is to Glomerodesmida. And so the names might not be useful to you again, but the cladogram is really useful because it has a visual representation of who is in the same kind of little branch together, who branched out a lot further on the left from each other. Now, I want you to highlight the important parts. Well, we're talking about a cladogram, so the cladogram itself is really important. And then I want you to recognize that this question is asking about which best describes the relationships. It's not saying, is this right? Is this wrong? It's asking you which of these statements actually is true or makes sense. You got to be careful too. All the phrases inside the answer choices are asking you about this is more closely related to this than this is to this. So there's always a comparison in every single one of these answer choices. And so you got to make sure that you're marking out which ones are being compared at a time. The question is asking about the relationships between the millipede orders in the cladogram. It is asking me to compare two relationships at a time to see which one is a more close relationship. That's what the question essentially is asking. So we know that the cladogram goes from left to right, which means that the millipedes that branched apart close to the right side are more closely related than the ones that branched apart close to the left side of the cladogram. I will need to count how many splits exist between the pairs mentioned to determine their closeness. At the very end, if I'm looking at them, Spirostreptida and Glomerida, I have Spirostreptida all the way second to the bottom. Glomerida is kind of in the middle up here. They branched apart 1, 2, 3, 4 times. Spherotherida and Glomerida. Spherotherida is up here. It's right next to Glomerida. So Spherotherida is really close to Glomerida. So this statement is false because it's actually the opposite. The third choice here says Polyzonida is more closely related to Glomerodesmida. Polyzonida is up here in the middle, and Glomerodesmida is up here. There's a 1, 2, 3 branching distance. And then Spherotherida to Glomerodesmida are right next to each other. So they're neighbors. So there's only one branching event. So again, this third answer choice would have been correct if it was the exact opposite flipped. This fourth answer choice is Mariquita compared to Glomerodesmida up here. And then Glomerida compared to Glomerodesmida. Again, Glomerida and Glomerodesmida are in the same branching event versus Mariquita is 1, 2, 3, 4 away. So again, F is the correct answer because the other three choices are exactly wrong. I'm going to ask that you do independent practice now. We have the STAAR question strategy, again, that you're going to follow in order to get credit. There is this question, and this question. I think that's it. There are 3 questions for you to work on. Make sure that you're following all the steps, highlighting, asking the question in your own words, sharing your knowledge or logic, and then eliminating and choosing the best answer. At the very end, you have an exit ticket in the Google Classroom, and then you're done for today.